Hi guys, welcome to the point slope form review presentation. Notice that this is a review lesson, so if you didn't do the original point slope form lesson from Monday and Tuesday, you should stop here and go back and do that now. In fact, it's always a good idea to do all of your math lessons in order, so you should not just be starting today for the first time in the middle of this lesson. Backtrack to the first lesson you haven't done and start there. Let's get started. Some updates and announcements. If you ever have any questions, please email me right away at bmcneely@riversidehighschool.org. During the workday, I can usually answer you back almost immediately, and usually if you email me the night before, I will have responded by the next morning. It's not too late to turn in late work. Don't forget that you can do anything from quarter 3, hand that in, and then email that to me, and we'll get that put in the gradebook. Make sure that you're using a pencil and paper and you're ready to take notes and try the U problems as we go. Be sure you're using your school email address. If you don't know how to do this, log into your school email address. Please email me and I can help you get it figured out. Struggles and celebrations. My struggle this week is that many students are not bothering to watch the video or take notes, and then they're getting low scores on the IP. These assignments are not meant to be done without watching the lesson first. Good job to those of you who are watching the videos and taking notes. Don't forget that you can always pause on working on your IP and go back to the video to look again if you have a question about something. My celebration is that more students are emailing me about what they should do to get caught up. Shout out to Terry Alexander, Kanye Shelton, and Janiyah Thomas for emailing me first thing this morning about things they could do to improve their scores or make up their missing work. Keep up the good work. All right, right now I want you to go ahead and pause the video and try these review problems on your own. We'll go over them together when you're done. Go ahead and pause now. Welcome back. You should have looked at this first equation and noticed that we want to get rid of these parentheses. Unfortunately, I can't add x and 3 because they are not like terms. So your first step in solving any equation that has parentheses is to distribute. When we distribute, we're multiplying the number in front of the parentheses times both of the terms on the inside. So this becomes 2x plus 6. The 8 is not in the parentheses, so we just bring it down. Now we have a two-step equation. Our job is to isolate x. We're going to start by getting our like terms on the same side. So we're going to subtract 6 from each side. The 6's cancel out, and you're left with 2x. 8 take away 6 becomes 2. The x is not yet isolated, so we're going to divide both sides by 2. The 2's cancel out, and so x becomes 1. Nice job. This one is very similar. We start it the same way. We have parentheses, and we're going to start by distributing. So we have negative 4x plus 12 equals 2x plus 20. Notice that now the difference is we have two sets of like terms on opposite sides, whereas here we only had the 8 and the 6, which were alike. Now we have the negative 4x and the 2x, they're like terms, and the 12 and the 20. I'm going to start by subtracting 2x from each side. What that will do is it will make the 2x's go away. Be careful here, negative 4 minus 2 is not negative 2. Negative 4 minus 2 is negative 6x. We bring down the plus 12, and we bring down the 20. Now it is just like this step. We're going to get the like terms on the same side, bring down the negative 6x, 20 minus 12 is 8, divide both sides by negative 6, and so it's okay to just leave this as a fraction, but we should reduce. 8 and 6 are both divisible by 2. 8 divided by 2 is 4, and 6 divided by 2, that should be 3. Nice job. All right, pause the video and try these problems on your own. We'll go over them together when we're done. I want you to notice something about this first problem. There are two fractions that are equal to each other. This is what we call a proportion. We solve any proportion by doing what we call cross-multiplying. Hint, hint, you're going to want to write that down for later. In a proportion, we are cross-multiplying. So we're going to multiply 5 and 2x plus 4 on one side of the equal sign. Bring down our equal sign, and then 8 and 3 on the other side. And then this is almost exactly like what we were working on the previous slide. Distribute to get rid of the parentheses. So we have 10x minus 20 equals 24. Add 20 to each side. So 10x equals 44. Divide both sides by 10. The 10's cancel out. And we have 44 over 10. Notice that both 44 and 10 are even numbers, which means they're divisible by 2. So 44 divided by 2 becomes 22, and 10 divided by 2 becomes 5. This one is not a proportion. This one is just an equation with fractions. It's not special like the proportion. The proportion has two fractions equal to each other. This plus 4 makes this not a proportion. So I can't solve this by cross multiplying. What I can do is multiply each side by the common denominator. Hint, hint, you might want to write that down. When you're working on an equation that has a fraction, you want to multiply both sides by the common denominator. We're not cross multiplying like on the proportions. So the only denominator in this one is 3, so I'm going to multiply every term by 3. 3 times 2/3 x plus 3 times 4 equals 3 times 4/3. Remember, we divide by what's on the bottom and multiply what's left times what's on the top. There's nothing to cancel out here. 3 times 4 just becomes 12. Here, 3 divided by 3 is 1. 1 times 4 is 4. Now this is, again, almost exactly like what we were working on the previous slide. Subtract 12 from each side. We get 2x equals -8. Divide both sides by 2. The 2's cancel out, and so x equals -4. Nice job. I wanted to go over a couple of problems from your last IP on form review that we had trouble with. Number 10 asked you to write the equation in standard form after you were supposed to have worked it out on a separate sheet of paper. Now, I had some people who said this is already in standard form. I have a feeling those people were not watching the video. This is not standard form. This is slope-intercept form where the y is already isolated. In standard form looks like this: ax plus by equals c. The x and the y are on the same side of the equal sign, and there shouldn't be any fractions. So I'm going to start by multiplying everything by 3 to get rid of the fraction. So it becomes 3 times y, 3 times -1/3 x, plus 3 times 6. The 3y just comes back down, but here the 3's cancel because 3 divided by 3 is 1. 1 times -1 is -1x, and 3 times 6 is 18. And I had several people who told me that the next thing to do is divide everything by 3, but that's not true. Remember, we want the x and the y on the same side. So our goal is to move the x to the other side by adding 1x to each side. So I get 1x plus 3y equals 18. That is standard form. We've got a whole number with an x, an integer with the y, and an integer by itself. Would you please pause the video and try number 11 on your own now? You should have started by multiplying every term by 3 to get rid of the fraction. This becomes 3y. The 3's cancel out. 3 divided by 3 is 1. 1 times 2 is 2x, and 3 times 5 becomes 15. Now I'm going to subtract 2x from each side, but I'm not done. It looks like the one we just did. It's got a number with an x plus a number with a y equal to a number by itself. There's no fractions, but I have to instead divide everything by -1 on both sides so that a can be positive. So this should have become 2x because a negative divided by a negative is a positive, minus 3y because a positive divided by a negative is a negative, equals -15. Nice job. All right, I want you to remind you why we use point slope form. Remember, slope intercept form looks like this. We use that when we have the slope and the y-intercept. But we won't always be given the y-intercept. Sometimes we're given something like this, where we have a slope that's equal to -4 and a point. Remember, mathematicians aren't very good namers sometimes. They're not very creative. So they came up with this equation called point slope form. All we're doing is the same thing every time, substituting into the blanks. So we're doing y minus 5 equals -4 times x minus, and then be careful, there's already a minus in the equation, and the 2 also becomes negative. So this becomes, we're just going to stop there because it says to write the equation in point slope form, and we're done. The one thing you might want to do is do keep, change, change to get those negatives away. Remember, it's the same steps every time, the same blanks that you're filling in. We have y minus, remember this is x1 and y1, so it's y minus 4 equals 7 times x minus -1. Again, you could do keep, change, change. You can stop because the directions say put this in point slope form. Pause the video now, use the previous 2 problems as an example, and try this next one on your own. Remember, it's the same steps every time. We have y minus the y value. Remember, this is our x1 and our y1. This is the slope, so the slope goes right here, and the x value is 11. Again, I'm going to do keep, change, change here. No need to do that on this one because the two minuses aren't together, and you're done. Good job. Let's try a few more. Remember, we're using point slope form, so it's the same set of steps every time. We're going to substitute into these blanks. Remember, this is your x1, this is your y1. We have y minus the y value equals the slope times x minus the x value. It's okay to go ahead and do keep, change, change on this one, but not on this one. There's no negative there. It's just the minus that was in the original problem. Same set of steps every time. Write yourself your blanks to help you. This becomes y minus a negative 2. Slope is negative 1, and x becomes negative 3. It's okay to do keep, change, change. This one doesn't have any minus in front of it, so we don't do that. Keep, change, change, and we're done. Go ahead and pause the video and try this next one on your own. You should have given yourself your blanks to fill in. Label this as x1 and y1. You should have substituted in the y value is 1, the x value is negative 5, the slope is negative 4. It's okay to go ahead and leave it like this, or go ahead and do the keep, change, and the change. So we have y minus 1 equals negative 4x. Oh, we're going to stop there because the directions said put that in point slope form. Good job. Now suppose we want to rewrite our equation in slope-intercept form using the given slope and a point. Remember, we're given a slope and a point, so we need to use point-slope form, which is y minus the y1 equals the m times the x minus the x1. You should write that down in your notes if you haven't done so already, so that you remember what point-slope form looks like. Same thing, remember we want to end in slope-intercept form. Slope-intercept form is y equal to the slope times the x plus the y-intercept. Again, you should write both of these equations down in your notes so that you have them later to work on your homework. We start with our point slope form just like we were doing on the previous slide. So this becomes y minus some blank times x minus some blank. So it's y minus 4 equals 2 times x minus negative 2 because this is your x1 and this is your y1. Now, the difference between what we were doing before and what we're doing now is we want to turn this into point slope form. Well, I see that right away I can do keep, change, change, and then I can distribute to get rid of the parentheses. So we have y minus 4 equals 2x plus 4 because I distributed. 2 times x is 2x and 2 times 2 is 4. Now we're going to add 4 to each side. So we have y equals 2x plus 8. Because the y is isolated, I've got the slope with the x and the y-intercept by itself. Go ahead and pause the video and try this second one on your own. This one becomes y minus blank equals blank times x minus blank. This is your x1, this is your y1. Your y1 is negative 5, your slope is negative 3, and your x1 is 0. You can do keep, change, change, so this becomes y plus 5. And then here we distribute. Negative 3 times x is negative 3x. Negative 3 times 0 is 0. You don't have to write the 0 there, but I like to for consistency because I like to remember that there is something there. It's just invisible. We can subtract 5 from each side to get the y isolated. And so we get y equals negative 3x minus 5. Or plus negative 5. You can write that either way. That's part 1 of the video. Go ahead and close this out. Go back to haiku. And we'll continue in part 2 of the video here in a few minutes. Good job.